take a test, especially when it's online. Can anybody name those that have had me before? During a thunderstorm, tornado, hurricane, lightning storm, and you don't wait until the last day to take the test. Okay? Why? Somebody explain Murphy's Law to me.
Something can go wrong at will.
Say it one more time.
Something can go wrong at will.
Okay? If you wait until the last day to take the test, the sky is going to fall down and hit your house or wherever you're trying to take the test. I'm just telling you. All right? Now, I extended this test another, several days? I think it was another several days. I can't remember. And I still had people wait until the last day. Now, I got 19 people in this class. 3 had problems. 3. So, I'm just thinking, I'm a math teacher. It seems like to me that the problem is not with me, and the problem is not with WebAssign. And that's all I'm going to say. I'm not saying that y'all are crazy. I'm just saying that if I give you a week, 2 weeks, a week and a half, 5 days, 3 days, if I give you a certain amount of days to do a test, don't you think you ought to try to do the test a couple of days before the deadline? Especially if I give you 3 forms. And not wait until the last day when you can't get anything done. Do you see what I'm saying? Now, I'm not picking on anybody in this class because I have to go through this speech every semester. My 109s and 130s. Have y'all heard this speech before?
Yeah.
I didn't hear you.
Yes, sir.
Thank you. Okay? I don't know why people wait until the last day, especially when they're on a new system or a new class, and they wait until the last day. Some wait until the last. I actually had somebody wait until 2 hours before the exam ended to start thinking about worrying about the test. So the reason I'm telling you this is because I don't want to hear any questions about the test today. I'm too irritated. All right? Now, my 103s and 130s, do I let people go throughout the semester without being able to make up a test or homework they missed? No, I don't. So if you miss this test, don't worry about it. Let's concentrate on Unit 2. We'll worry about taking Unit 1. Not today. I don't want to address any questions on that today. Okay? Does everybody understand that?
Yes, sir.
Okay. I've got that off my chest. I feel a little bit better. Murphy's Law is Murphy's Law. You don't play with it. Don't wait until the last day. All right. Now, we're going to start Unit 2 today. Now, if you go by the book, it's very, very difficult to see what you're actually doing. But what we're actually doing is more integration. And these are called uncommon integrals, or what was that? Or integrals that are indefinite. Okay? Half definite, half indefinite. But first, I want to go over a couple of things before we talk about indefinite integrals, or whatever they're called. I don't know what they're called in this section, but uncommon intervals. All right, who is that right there? Mr. Frederick, are you there? I want to make sure you're there because I don't have a video on you or Mr. Stone.
I'm here. I tried to turn it off and turn it back on, and it's still not working.
That's fine. That's fine. I just want to make sure I can hear you. Let's see. Go ahead, Mr. Stone. What were you saying?
Is my video not working?
I don't see you. I don't know what happened there. Let Let me turn that back off.
I'm trying to. I don't know what's going on, but I'm here.
Okay. Okay, now it's working.
Oh, okay.
Gallery view. Okay, the only one that's not working. Okay, I know what's happening. What's happening is when you speak, it engages, but Mr. Frederick, I don't think it says UCAM 6 on yours. It doesn't even. It has your name and UCAM 6. I don't know
Yeah, I
what
think that's
that
the
is.
camera that's in my computer.
Hold on a second. I'm just. Oh well. Pick a layout. Speaker view. I hate when it does this. Okay, now it's working.
Okay, I just turned it on in the app. I don't know if it's going to turn off if I close the app, though.
Okay, Mr. Miller or Mr. Granger, say something, please.
I'm here.
Oh,
Well, you got to say more than that.
Me or Austin?
Either one. I need you both to say something because I want to see if you're. Just say a sentence. Say something you memorized in school or something.
I had a good weekend.
God, this is pathetic.
how was your father's?
Y'all
That's
pretty
what he
much.
memorized in
Y'all know
school.
that. Just
That's
forget
what
it.
Tri-County taught him. I had
Yeah,
a good
exactly.
weekend.
I just give up. All right. So there's two things that we didn't cover in the last section that I want to cover just in case. Substitution, integration by substitution, and integration by parts. Now, I do not know how many of you have had an exposure to this, but we're going to review over it. We'll do it by hand, and I'm going to try to follow the same thing that I did in the last section. We're going to do some by hand, then we're going to look at what the book shows us, and then we're going to look at doing it by hand versus a calculator, because that worked in the last section, so we're going to try it in this section. Let's go with something like the antiderivative of the cosine of 3x plus 4 dx. Okay? Now, one of the reasons you can't do this as a regular antiderivative and integration by parts is because you got some kind of multiplication thing going on. Here, you have the cosine of something. So technically, you have kind of two terms there, and you have not done integration with two type terms before, and you do that especially right here when you have multiplication. You've been doing the antiderivative of 4x dx, where you can pull the constant out and you're left with just one term. That's what y'all are used to doing and y'all are used to seeing. But in this section, you're going to see some different types. So I'm just going to cover the worst case scenarios. And that way, if you know the worst case scenarios, you can fall back and say, oh, these are easy. So what do you do first? Well, you say to yourself, u, and y'all remember u. We used u for u substitution a good bit in algebra as well as in the first part of calculus. So u is equal to whatever is the mess. Usually the hardest thing, and of course you're not going to make it equal to cosine because that wouldn't be, you could, but it's not going to help. But that's going to be this area right here, 3x plus 4. Now, when you use u substitution with the antiderivative, the first thing you're going to do is take the derivative of u to get what? du. Because your goal is to set up some kind of u du scenario. All right? Because if you have u du, then all you have to go back to is the power rule, which that's the only rule that you know of integration. Does everybody understand that? Just think of this as u to the first power. And what's the antiderivative of u to the first power? Say again, I heard a blip. What? What's the antiderivative of u to the first power?
U squared over 2.
U squared over 2. What's the antiderivative of u to the third power?
U fourth over 4.
Okay, so once you get it in the form of u du, you can take the antiderivative. Then when you get the antiderivative, you can plug the u back in. All right? So, what is the derivative of 3x plus 4? 3 d what? 3 dx. Now it's very important that you put that dx right there. Very important. Because in all your antiderivatives, you're always going to have a what? A dx. So that dx down there is important. So we need to make this right here appear right there. But we don't. So we got to add something to the antiderivative. What do we add? A 3. Now, if we add a 3 to the antiderivative, we have to pull something outside here. And what do we add out here? A 1/3. Right, write that down and let it soak in. You need to write it in your notes however you need to, because this is your second basic law of antiderivatives, or your second basic law of integration. It's substitution. So you need to write it down, or what I just did there. Now, there's another way to show it. Another way to show it is to say u is equal to 3x plus 4. And I'm just going to erase this integration by parts over here. There's several ways to do it. And I'm going to show you just in case you see it in a book or somewhere. U is equal to 3x plus 4. And du is equal to 3 dx. But I'm going to solve for dx. And I get 1/3 du is equal to dx. Okay, that's another way to do it. Now, I don't do this way because it confuses students. So I just kind of show it to you and say, if you see it, it's the same thing that we're doing over here. Same thing. Okay? So, now I have 1/3. Oops, sorry. 1/3. Oops, no, I don't want to do that either. Antiderivative of the cosine of u, and what is 3 dx? So now I have the integration of the cosine of u. And what is the antiderivative of the cosine of u? Sine, thank you, class. So that would be 1/3 the sine of u plus what? Plus c. Now what is u?
3x plus 4.
I'm sorry, what?
3x plus 4.
Thank you. So that's going to be 1/3 the sine of 3x plus 4 plus c. And that's by substitution. So, what did I do? Well, I picked the most complicated thing, and that's equal to u. Then I took the derivative. The derivative of u is du. The derivative of 3x plus 4 is 3dx. And then I said, wait a minute, I've got a dx up here, so I just got to put a 3 in there. If I put a 3 in there, then I got to put a 1/3 out here. If I put a negative 5 right here, what's got to go out here? A negative 1/5. If I put a 1 over 5,000 right here, I got to put a 5,000 out here. Because what's the reciprocal times the reciprocal? What's the reciprocal times the reciprocal? 1. So I'm multiplying the whole thing by 1. Does everybody see that? But what I'm doing is I'm manipulating it. I'm taking it and I'm manipulating it. So now I have the cosine of u du. The only thing is this 1/3 has to stay out there. Cosine of u du. Cosine of u du, the antiderivative of cosine is the sine. And boom, you're done. All right, let's try another one. And again, if I was to say this is a law, this would be your second law of integration. Your first law is the power rule. This is called substitution. I'm going to let y'all try this one. Antiderivative of 1 over 1 minus 2x dx. Okay, 2 good horror movies are coming out.
Yeah, have you seen
coming out October the 19th, and then The Nun is coming out in September.
the one that's out right now?
Horror movie?
Yeah.
2 good movies.
Look.
If you saw The Conjuring 2, then you know who The Nun is.
Now, have you seen the one that's out right now?
Which one?
Oh, Hereditary. That's what it's called.
I'm going to see it when it comes on Fire Stick.
I heard it was really good.
Well, good. I've seen the trailers. It looked like it would be good.
I thought you'd be excited about that because I heard it was really
am.
good.
I just haven't, with Father's Day and everything, and having the kids all weekend and driving me crazy. No, I'm just kidding. I just haven't had a chance to get to it or look at it.
Yeah.
But I am excited about watching it.
Made me think of you.
Huh?
Made me think of you.
Did you see it?
No, I didn't get to see it. All my buddies went to go see it. I was still in Colorado. Getting really high.
Well, whatever. Got no use for no pothead, so I ain't gonna say.
I'm just kidding. All
right.
Where's my mom? You think my mom's gonna let me get high?
Well, I don't know. Have you seen Live PD the other
Dude, my
night?
mom would beat
You
the
had
hell out of me.
a mother strung out on meth, and her daughters were being pulled into it because the mother was on meth. I swear to God.
My mom beat the hell out of me. My
Good,
dad
I'm
would
glad.
just shoot me.
She ought to. All right. So, what am I going to make u equal to? Thank you. So you're the one. 1 minus 2x. So what's the derivative of 1 minus 2x? Negative 2 what? Don't forget the most important thing. Negative 2 what? Dx. Okay. Hubert, I've got a dx right there. But I've got to put in something. What have I got to put in? A negative 2. And then I got to put a negative 1/2 out here. Now I need to rewrite it as negative 1/2 antiderivative. Okay, 1 over what? 1 over u d what? du. Okay, finish it. Now, what is the antiderivative of 1 over x? ln of what? X. So this will be the ln of u. Now, what do you have to make sure you put on a natural log?
Parentheses.
Absolute what? Absolute value marked, because you can't take the natural log of a negative. Now, I'm not through yet, but that's kind of my setup. What have I got to do now?
Plug it back in.
Plug in for u. So that's going to be negative 1/2 natural log, absolute value, plus c. And what is u? 1 minus 2x.
1 minus 2x.
You would be surprised on how many people have went through calculus and did not know how to do substitution. It's really simple. But you have to go through it in a very methodical way. And that's it. You got to find u. Once you find u, plug it in. Question on those 2 examples of u substitution. Okay? I'm going to give you a homework assignment with u substitution. It's just going to be called u substitution. And I'm also going to give you one on integration by parts. And we're fixing to go over that, kind of a review. I don't know if it's a review for some of y'all, I don't know. But we're going to treat it as a review or semi-review. All right, integration by parts. Ultraviolet minus voodoo. What in the world is Hubert talking about? Well, when I teach my calculus students in Calc 2, that's the way I teach it to them. Integration by parts. When you have 2 terms and they're multiplied, you use ultraviolet minus voodoo. U times V minus the antiderivative of V times du. Ultraviolet minus voodoo. And that's the way my Clemson professors explained it to me. They didn't do all that stuff that the book does. They just said ultraviolet minus voodoo. Let me find one right quick. I got a couple that I have. Because I didn't want to go right into, I only got one example of this. There it is. And we're just going to do the first part of it. The antiderivative of s times e to the negative 5s ds. Okay, write that down. And then make sure you got a clean sheet of paper. If you wrote this integration by parts at the top of the page, that's fine. You can still use that page. Just if you're at a half a page or you need to move over to the next page of your notes, because it may take a little bit of area in your notebook paper to do this problem. First of all, you have to designate your first part and your second part. The first part is S, and the second part is E to the negative 5S. And you can put you a little multiplication symbol in there, and boom, that's the little flag that tells you, I can't use my first or second law. I have to use integration by parts because I'm multiplying 2 terms in an antiderivative. So, best thing to do is probably quit, isn't it? Because it's complicated. First thing I'm going to do is find a u. Now, it really doesn't matter which one you do, but in this case, I'm going to make u equal to s. All right? Why am I not making it? Because the antiderivative of e to the negative 5s is pretty simple. So I'm going to make that dv. Now you always pick a u and you pick a dv. You always pick one of the two, or you pick both of them. Okay, actually, they tell you this right here. The antiderivative of u dv is equal to this. And they tell you that the first term is u and the second term is dv. So this is u and this is dv. But you don't have to follow that 100% of the time. You can make dv be the second one, the first term. It's kind of, feel your way through it. It's not that you have to do it concrete, but, in this case, we're going to make u equal to s. And this is the way that I do it. They don't do it like this in the books. I put u right here. U is equal to s. And then I put dv down here is equal to e to the negative 5s. Okay, because now I'm going to go down right here. So let's mark these. I'm going to take a highlighter and we're going to make it yellow. And I'm just going to put given. That's given. And then green. This right here is right here. So those two things, you don't have to do anything. You just have to look at the equation and how it's. See, there's the green. And there's the u. Now the reason I'm being so graphic, or I'm trying to, these things are not that difficult, but you'd be surprised on how many students quit calculus because they can't do integration by parts and they can't do substitution. And if you will look at both of them, they're not that difficult. It's just a methodical thing that if you're not taught the method or the pedagogy or the steps, if you're not taught the steps at the initial beginning, then you can just kiss it goodbye because you're not going to get it. So now I'm going to take my handy dandy black, I'm going to draw a line here, arrow going down that way, and an arrow going up this way. Here I'm going to take the what? I'm going to take the derivative. What am I going to do here? Here I'm going to integrate because I'm going from dv to what? To v. And here I'm going u to what? du. So it's very important that you write those two notes down. The arrow going down, you're going to take the derivative. The arrow going up, you're going to take the integration or the antiderivative. I'll do this one for you. I'll do s. The derivative of s is ds. There, I did that one for you. Now you do the other one. Take the antiderivative of e to the negative 5s. Now we've talked about that when we first started, so you should be able to get it. Remember, take the derivative of what's inside. And the derivative of e to anything is what? E to anything. But is this different? Yes, because the negative 5s is what's inside. So after you take the derivative of e to anything, you have to take the derivative of what's inside, which is the negative 5s. Anderson campus just didn't decide to come. Miss Kubu, I appreciate you being not belligerent. I appreciate you being committed. And Mr. Stone, I give you kudos too for at least Skyping in.
Oh yeah.
All right. So what is the antiderivative of e to the negative 5s? E to the negative 5s, Hubert. E to the negative 5s. But what did I tell you? Always goes on the bottom of what's inside. So what is the derivative of negative 5s? Negative 5, Hubert. That's right, class. And that's it. Or you could write it negative 1/5 e to the negative 5s. Either way, I do it that way because it's easier. Now what do? Simply what? Plug and
Chug.
chug. Plug and chug. Well, what are you plugging and chugging into? Well, what do we had? We had this. So if I had this, then what's the only thing I can plug and chug into? Ultraviolet minus voodoo. So what do you mean plug and chug? Well, where there's a U, what are you going to plug in?
S.
Thank you. Well, V, what are you going to plug in? All that trash. E to the negative 5s over negative 5. All right, get to it. Plug and chug. Now, this is where some of your algebra is going to come in. Remember, if you suck at algebra, you're going to suck at calculus. Got to simplify a little bit. What I'll do is I'll take a little blue marker and I'm going to highlight this in blue. So that means you need to do it. If you've never seen this before, you need to highlight this. Once you have those four things done, you got to plug and what? Plug and chug. So now we've got S times, I'm going to write all this out because I got to refer back to my algebra that I suck at, e to the negative 5s over negative 5 minus the antiderivative of what? What's v? Well, same thing. E to the negative 5s over negative 5. And what do you think is always going to be du? ds. So now I can take the derivative. The reason I couldn't take the antiderivative of this before is because it had two what? It had two what? Two terms in it. Now what does it have? Just one term. All right, finish it. Now, 90% of you should be able to finish that because you pull the negative 1/5 out, and then you take the antiderivative of e to the negative 5s, which you already know the antiderivative of e to the 5s is what? All that trash, Hubert. That's right. So, really, the third part is not really any thinking at all, is it? No, Hubert. I'm sorry for being in a bitchy mood this morning. I'll go ahead and apologize. It was all that heroin I did this weekend.
Happy Father's Day, right?
Yeah. I think my 11-year-old got some bad stuff.
What's that?
This 11-year-old got some bad stuff.
I'll take care of getting it next time. All right, so that negative 1/5 can come out. That's not a big deal. You can't do really much of anything with this except maybe pull that negative 1/5 out to the front. And you don't have to do this, but negative 1/5 s e to the negative 5s. Could you pull that e to the negative 5s down? Yes, you could. You could make that s over negative 5e to the 5s, you could do that. I'll write that down also. You could do s over negative 5e to the 5s. Do that. I really don't care about that because that's trivial at that point. I really don't care. But you might have some problems with WebAssign on the homework. So just realize that you could rewrite this 3 different ways. Again, that's nothing but 100% what?
Algebra.
Algebra. And I don't agree with using 5 and s in the same problem. That's not really my decision. That's the example that I got. All right, so here we go. What am I going to do with that negative 1/5? I'm going to yank it out because it's a constant, and that makes this positive what? 1/5 antiderivative of e to the negative 5s ds. Oops, ds, not dx. Doesn't matter, but anyway. And you know that this is this right here. So I'm going to rewrite it right here, plus 1/5, and I'm going to put a bracket right here, and I'm going to put e to the negative 5s over negative 5, right? D plus c. I'm not worried about the plus c yet. Now, I want you to see if there's anything you can do to simplify that anymore. There's one more thing that you can do to simplify. And that is bring the negative 5 what? Out. So S, I don't care how you write this, negative 5 E to the 5S minus 1 over what? 25 E to the negative 5S plus C. Now, when I get to this point, and we're talking about doing integration by parts, and we're talking about doing integration by substitution, I'm not really concerned about the simplification of that first term or if you're writing it the same way. So I'll be very lenient if you're taking the test in Unit 2 and the WebAssign counts it wrong because you put this in as your first part of your answer versus this way, okay? I'm not really concerned there, all right? So try to feel out how they want their answers in the homework and then just apply that to the test, okay? Because they'll probably want it some way versus another way, and that's when you need to, the same way. Now, that's a soft skill, okay? What the heck is a soft skill? If a teacher writes all of their answers in terms of fractions, is everybody listening? If a teacher does all their notes on the board, and every time they get to an answer, they put it in 1/2, or 1/3, or 5/3, or 11 over 5, or whatever, should you go to the test and start writing in terms of decimals?
No.
Thank you, Miss Nethercutt. That's called common what? Common sense. All right? Same thing with your homework versus your test. If you go through your homework and they like for you to bring that 5S down on all your negative exponents, they notice on all the answers that you put, they want it down, then chances are the test is going to want it that way too. Okay? Now, this is a problem. Mark this as a problem in 8.1, or what chapter are we in? 6.1. All right? This is a homework problem that I'm going to give you in 6.1. Now, there is a continuation of this because we're dealing with a definite A, and a indefinite b, which is infinity. Okay? And we're going to talk about divergent and convergent and all that good stuff. But that's later. We got to make sure everybody knows how to do the three types of integration. Okay, let's go over the three types one more time. One, you got to be able to do the power rule. Two, you got to be able to do substitution. And then three, you've got to be able to do integration by parts. Now, I doubt very seriously that this book is going to do this one. Okay? I don't think they're going to do integration by parts. But I would rather you be over loaded for bear going into a test or the homework than not be loaded for bear. So that's why I'm going over this, so that way you have it. Let's do another one. Let me see if I can find one, because I only had one example. Let me go to the internet and see if I can pull up a couple. If it doesn't shut everything down. Up another page. Okay. Go tab. Let's go with integration by parts. Integration by parts. Sample problems. PDF. Go. All right, try number one right there. X e to the x. X e to the x. And that's pretty simple. That's one I would give you on a test. That's a test question right there. And number 3 is a test question. Number 2 is a test question. So let's do number 1. X e to the x. And I need to put this marker somewhere else, so I do not need a marker. X e to the x. Go back to the whiteboard. X e to the x. Antiderivative. X e to the x dx. Now, knowing what you know from the last problem, what would you make u?
X.
Good job. Are you gifted and talented? dx. What would I make dv? I'm sorry. What would I make dv?
E to the x.
E to the x. And again, it follows in that same format of antiderivative of u dv is equal to ultraviolet minus voodoo. So we're giving u and we're giving dv. So you draw your arrows, and this is a Hubertism because this is what I did when I was a student. I put a D here and I put an I here. The derivative is equal to what? dx. So du is equal to dx. And I'll do this one for you. V is equal to e to the x. I did that one for you. Aren't y'all impressed that I could do that so fast? Now, plug and chug. And a lot of you are saying, well, he's showing us the same type problem. Yes, I'm showing you the same type problem. Why? Because this problem the calculus is not what's going to get you. What's going to get you? Not the algebra. What's going to get you? The methodology. Okay.
Methodology.
Thank you. Are
you high, dude?
Say mythology.
Bad heroin.
Are you
Yeah,
drunk?
it is.
What's going on?
What's that stuff that goes on heroin that can kill you? What's it called?
Heroin?
No. They lace the heroin with something to make it stronger.
Yeah, they mix it with
They have to-
fentanyl.
and
and
it-
really
it-
goes in.
Fentanyl.
That's it, fentanyl. That's what it is. I got some too much fentanyl.
Y'all talking about fentanyl?
Oh wait, you got some of that fentanyl.
How do you know I know that? I watch live PD. That's why I got to
Sure
use
you
them dang old
do.
rubber gloves. Dang old, because them dumbasses might as well just snort rat poison. Idiots. Yeah, let's get together and let's crush up this rat poison and snort it. Maybe this last tooth will fall out of my head if I do that. I'm sorry. I ain't never had use for drugs. Period. Call it the redneck country boy. I just ain't never had no use in it. All right. So plug and chug. I'm gonna go over here and plug it in. What's my U? My U is X. My V is e to the X minus antiderivative of e to the X dx. And look over there. What is the antiderivative of e to the X? I'm going to let Mr. Crawford do that one since that one's so complicated. What's the antiderivative of e to the X, Mr. Crawford? He's not going to talk to me. Is he ciphering or is he there? Is he
Marshall.
there?
Are you not listening? He said your name like 5 times.
What?
What's the antiderivative?
He's watching that porn. He's got his earplugs in watching porn. What's the antiderivative of e to the X? E to the X, Hubert. That's right, Mr. Crawford. Thank you. So, what? Now, here's another thing. Here's where you need to, when you're doing your homework, see if there's a pattern. Here, you could factor out what?
Just go back.
Kick me, dude. Kick me. Something.
There's your answer. All right, let's try to find one that doesn't have an e to the X in it, so y'all won't feel like y'all didn't get your money's worth today. Well, there's not much of all of them. Ooh, I don't want to do that one. That one's too long, drawn out. Well, all of them are, except for, and I'm not doing trig because we don't do trig in here, so I don't have to do that one. So I tell you what, I'll just give you these. Number 1, write it down. Number 3, write it down.
Switch to number 1.
Number 10, write it down. And that'll be 3 good problems for you to be able to work on. Well, we could actually, let's do number 3. Since it's got a negative 4x, let's see how well you paid attention to the first one we did. Go ahead and do number 3. Now, 11, 13, give you 2 minutes to get it started. X e to the negative 4x. X e to the negative 4x. And I'll go back to that page if I need to, for those that need to write it down. And I'll pull some more problems from that for you to study for a test. Antiderivative of x e to the, what was it, negative 4x?
Yeah.
Now, the reason I'm showing you this one again is to see if you can follow the methodology from the first problem we did. And if you can do the methodology, you've got it licked. Mr. Miller, where are you at?
I'm in my room. I'm like.
You looking, okay. I thought that's a nice
I'm in my room.
closet door, you know.
Oh yeah, behind me. Yeah.
So y'all made Miss Kubu mad. She's leaving.
What'd you say?
Y'all so offensive.
I didn't hear you, Hubert.
What made somebody mad? She left.
Did she get her feelings hurt?
Yeah, something about you watching porn in class.
I bet it was you talking about meth, man.
Yeah, hopefully.
It was heroin.
Heroin. Yeah. Get your drugs right, man.
Dude, I bet Hubert and my dad would get along great.
Why do you say that?
Because you act just like my damn dad.
Was he a former Marine?
No, he
Okay.
just grew up in Pickens. So basically,
I know people that can make 3 syllables out of Pickens.
me too.
Pickens. They make 2 syllables out of the P-I-C-K. I don't know how they do that, but they do. Pickens.
Y'all also blame the government for a lot of stuff, which I think's really funny.
He blames the Russians.
No, I don't blame the government. I blame the swamp rats that are up in D.C. That's who I blame. Just like right now. Okay, I'm going to pick on something that's nonpartisan. The immigration situation. Okay?
Okay, Dad.
We got problems with immigration, but does it get fixed? No. You know why? Because we got a bunch of right-wing nut jobs that are just about on the edge of being racist. They call themselves the freedom something. Okay? And then we got the left wing that don't want to do anything because they hate Trump. Meanwhile, we got kids down living in bunk beds, which are nice little bunk beds. They get, because their parents broke the law. Well, I'm sorry. We got to take care of the kids. But we're not obligated to take care of the parents and the kids. But we got to fix that. Dadgum people break the law. Dadgum, they need to think about their dang old children.
Happy Father's Day, Hubert.
What?
Happy Father's Day.
Yeah. Dang old put up a dang old wall. Dang old won't be coming over.
Dang, I'll put up a dang old wall.
Let me ask you a question.
Ask
Mr.
away.
Crawford, let's say you and your future wife go to Six Flags and you got 3 kids and you sneak those 3 kids into Six Flags and yourself. Y'all crawl over or go through the fence and you get into Six Flags without a ticket. What happens when they chase your butt down?
My ass gets thrown out of Six Flags. Simple as that. I don't have a problem with immigrants. I have a problem with illegal immigrants.
Six Flags is racist. Because they threw you out of the dadgum fence.
How did we get from Snake?
It's because they're racist because they don't include all the colors.
You,
Right.
DB,
Oh, yeah, that's physical.
Hey, so are you hinting towards we're going to go to Six Flags or something?
We taking a field trip?
Yeah. By the end of the day, somebody called my department head. My department head says, you can't take your kids to Six Flags. You can't take your kids to Six Flags. Because you
give
said
me,
that.
Give me a few more weeks. I'll be actually ride roller coasters. My back.
Okay.
Did you make that?
Derivative,
We'll see it.
integration. Okay. So what are you going to pick? U is equal to X. And du is equal to dx. The antiderivative of e to the negative 4x, just rewrite e to the negative 4x and put what under it?
-4.
-4.
Y'all are so smart. Now plug in what?
Chug.
Plug in chug. Ultraviolet.
Chug.
X, v, parentheses, e to the negative 4x over negative 4. Ultraviolet minus voodoo. E to the negative 4x over negative 4 do dx. All right? Now, simplify and pull that negative 1/4 out. And that's it. You'd be surprised on the horror stories I've heard from people being taught antiderivative, doing it by parts, and people just tell me horror stories. So, negative 1/4 x e to the negative 4x. What's negative 1 times negative 1/4?
1/4.
Positive 1/4. Antiderivative of e to the negative 4x dx. Now let's see. I think somewhere we took the antiderivative. Yeah, we did, right here.
Is it one more step?
So the antiderivative of e to the negative 4x, which is this right here,
Or is it just another?
is the same thing, right here. Negative 1/4 x e to the negative 4x plus 1/4 brackets, and then we just rewrite this right here because we don't want to reinvent the what? You don't need to reinvent the wheel. If you've already taken the antiderivative of e to the negative 4x, please don't go through it again and do it when you got it written right over here. So that's going to be e to the negative 4x over negative 4 plus c. And now what's the only thing we can do to simplify? Bring out that negative 1/4, and that's going to be x e to the negative 4x minus what?
1/16.
1/16, good. Parentheses e to the negative 4x. Now, as far as factoring out stuff, and that's up to y'all and up to the book and up to the directions, I really don't care about that. I'm pretty good. I'm pretty satisfied with this right here. So again, if you do a couple of homework problems and they're factoring out a negative 1/4 e to the negative 4x, if you see that they're doing that on two problems, then chances are on the test you're going to need to factor it out. And that's what you would factor out. Why would you factor out a negative? Because you would make this a positive term and this a positive term. That's the reason you would factor out a negative 1/4. And the e to the negative 4x, that would give you a 1/4 on that right there, and that's it. So, it's up to you and the homework and the test on that. Okay, now, just to reiterate, we've just reviewed and went over, and I'm going to pull up that problem page again. So for some of y'all that didn't get all of it, here it is. So make sure you can do number 1, number 3, number 10, number 1 down here. There's another one, number 1. Number 2. Any of those that have an X to the, these are definite. I really don't care about the definite because that's when we get to the calculator and we'll put the calculator to work on that. Just any of those E to the X's, okay? All right, now, 6.1. That's what we're doing right now. So 6.1, we're going to take all of our knowledge with the antiderivative and we're going to apply it to what we call an uncommon integral. I don't know what they call it, but uncommon integration. Uncommon integration is basically when you have a definite and an indefinite parameter on the integral. All right? And where that comes from, and all you business majors, when you got something like this, or you have something like this. Okay, now there's different applications. You got the natural log curve, you've got the e to the x curve. I'm not going all over that, but basically you have a decreasing and an increasing curve. Everybody with me?
Yes, sir.
Okay, and it's usually in the first quadrant. So this is your business application. Here, we're going to drop down a line right here and say this is 1. There. And it just keeps on going. Like that. All right? Here, we've got that same beginning, but here it just keeps on going. And we know the area under a curve is given by antiderivatives or integration, but what do we do when we don't have an end or b? Well, somebody tell me what happens here. Well, this line is going to converge onto the x-axis. And this line is going to keep going up and over. So what is the area going to do on this one?
Bigger.
It's going to keep getting what? Bigger. That's divergent. It's going to keep expanding. It's going to keep going. It's not going to stop. The area is not going to get smaller. The area is going to keep getting what? Bigger. Versus, what is the one on the left doing? What is that line doing to the x-axis? What's the C word I'm looking for? It's kind of the opposite of divergent.
Priority 1 message coming in unsecured channel.
I think somebody mumbled it. Convergent. Now, what we're doing is we're using the limit theory. And you're going to be using the limit theory here in just a minute. The limit theory says that if I keep going and I keep dividing by n, if I keep dividing 1 by n, I'm going to get closer and closer to that line, but I'm never going to what? I'm never going to touch it. Therefore, that area is not going to change very much. Versus on the divergent, where that area keeps getting bigger and bigger because it's diverging from the x-axis versus converging. All right? Now, to do this, we're going to have to use the limit theory with integration. All right, so let's say this is infinity, of course. That arrowhead right here is called infinity. So that means that we're going to set up a limit with t, I'm just going to use t, approaching infinity of an antiderivative from 1 to t of f of x dx. Now write that down, because what you're going to do is you're going to find the antiderivative just like you've always been doing, okay? And that doesn't change. So you need to make a note of that. Number one step, find the antiderivative, okay? After you find the antiderivative, you stick a limit on there and you put 1 to t. T is supposed to be infinity. That's supposed to be infinity, not 0. I didn't write the second one, I guess. There we go. Same thing here. But what you're going to get here for divergent is when you do the ... means, as Dr. Harden used to say, that means you know what to do here. Okay? ... means you go through all the math and all the calculus and you get basically a what? A number. If you get a number, that's the area, then that is convergent. Then what do you think you're going to get with the divergent? Infinity. Now, the reason I'm showing you this is because there's the two types of problems you're going to have. All right? And in the homework or the test or whatever, it's going to ask you for either the area, and it's going to say, is it convergent or divergent? If you get an area, you get a number, whether it's a decimal, fraction, or a whole number, is convergent. That means it's an area. Here, if you plug in infinity, so like if I do all the work and I get x to the n power, and n goes to infinity. Well, what's any number raised to infinity? Come on, limit people, limits. What's any number raised to infinity? What is that number going to do? What is that answer going to do?
One message coming in on secure channel.
It's going to keep getting bigger. Yes.
Yeah.
2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power. It gets bigger and bigger and bigger.
And just get exponentially bigger.
Exactly. And it goes to what? Infinity.
Infinity, if you're raising it by
So
infinity.
if you go to infinity, then your answer is going to be infinity, therefore it's divergent. All right, so let's look at some. Y is equal to 1 over x squared. Now that's the way they're going to give it to you. They're going to give it to you just as a function. And you're going to have to set it up. Now, to set it up, you draw it first. You need to draw it so you can look at it. Now, you're business majors, so which quadrant do you care about?
Second.
The first quadrant. And this arrowhead is called infinity. And we're just going to start with 1. And in some way, they're going to give you what to start with. Okay? So the first thing you do is say, okay, well, I got to set up an integral. So that's going to be equal to the antiderivative from 1 to infinity of 1 over x squared dx. And this is what you're doing to set this problem up. First, you put it in terms of infinity. Okay? Then you change it to a limit. And I'm just going to use t. I don't care. You can use w. You can use whatever variable you want to. But I'm going to say, okay, limit as t approaches infinity of the antiderivative from 1 to t of 1 over x squared dx. Okay, now there's the setup. So in your notes for this section 6.1, you need to write step 1, setup. Step 1, graph and setup. I just did both of those. Now, what do you think step 2 is? Quit. Yeah, that's a pretty good guess. What's step 2? What I tell you was the most important thing, to take the what?
Antiderivative.
Take the antiderivative. Go ahead and do the antiderivative. If you want to, just take that 1 over x squared and pull it out and just put an integral sign in front of it and just do it over to the side. You don't have to worry about any of that other stuff. Just do the antiderivative of 1 over x squared out to the side. So I'm going to go over to the side right here and I'm going to say, okay, antiderivative of x to the negative 2 dx. And that's going to be x to the negative 1 over negative 1 plus c. Well, if I wanted to rewrite this, I could bring that down and it'd be negative 1 over x to the first, right? Everybody got that? So I'm going to rewrite this. Limit as t approaches infinity, parentheses, negative 1 over x, close parentheses, evaluated at 1 and what? T. So I go over here and I basically take this and I go over here and I do the antiderivative to the side, and then I come over here and I put it back in the form of a limit. And now I'm going to plug in what? What am I going to plug in? T and 1, Hubert. That's right, class. You're going to plug it in just like you would a definite integral. So plug in t and 1 and subtract it and simplify it, and then we'll get to the limit at the very end. So I'm just going to come down here and I'm going to write equals limit t approaches infinity. And then I'm just going to write a big old set of brackets. And I'm going to put negative 1 over parentheses minus negative 1 over parentheses and then close bracket. Okay, and I'm going to plug in a t here. I'm going to plug in what? A 1 there. Now somebody tell me something. I want to ask you a quick question. What I've done so far, is it very, very difficult or is it very methodical?
Methodical.
Very methodical. Very methodical. All right, what do you get? Well, if you simplify it, you're going to get equals limit as t approaches infinity, brackets, 1 minus what? All right, who's got questions? We're not talking about a lot of algebra. We're not talking about a lot of calculus. We're talking about just same steps. Now, what happens when you plug in infinity? 1 minus 1 over infinity is equal to, somebody tell me what that's equal to. I need two numbers. One number on the left, minus symbol, one number on the right. What are those two things doing? What's 1 doing? Nothing. So 1 minus what? Y'all settle down, raise your hands. If you don't all blurt out the answer at one time. What's 1 over infinity go to?
Infinity.
1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, 1 over 8, 1 over 9, 1 over 10. Somebody should say what it's going toward. 1 over 11, 1 over 12, 1 over 13, 1 over
1 over
30.
infinity?
What?
1 over infinity? Or is it just infinity?
Okay, starting over. 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Say again. I heard somebody say 0. 0 is going to what? 0. And what's 1 minus 0? So therefore, this function is what? Convergent. So that means that the area under this curve from 1 to infinity is equal to 1. Why? Because this area out here is so minute that it's not really going to add anything to the area. So therefore, that area is equal to 1, and it is convergent. All right, I'm serious. How difficult is that? It's not very difficult, Hubert. I didn't think so.
You talk to yourself a lot.
I know. It'd be nice if I had somebody to interact with me and make, class go by faster. But y'all suck, so that's why I talk to myself. All right.
You're growing your hair out?
Antiderivative of 1, no, it just hadn't got a cut. 1 to infinity of 1 over x dx. I'm glad y'all worry about stuff that really matters.
Hubert. Trying to be like Samson.
Yeah, I want to become a hippie and live in a van down by the river.
Who's the dude in the Bible?
Smoke pot.
He just he pointed his hair and then flexed his muscles.
What?
You know Samson in the Bible?
Oh, whatever. I'm gonna become a hippie. Yeah, I'm gonna become a hippie.
He got his strength from his hair.
You're going to
All right, so 1 over x. Draw it out. I'm ignoring y'all. 1 over x.
That's just because your muscles are making you.
You're blowing your head up too. Blowing up your arms and your head.
1 over x. Antiderivative 1 over x. It's pretty simple. You should know what the antiderivative of 1 over x is. But see if you can set it up. Because you have to set it up with the right nomenclature. You have to say limit as t. We'll use t. You can use n. You can use q. I don't care what you use, but I'm going to use t. So they've already set up the infinity for you. So all you have to do is say limit as t approaches infinity of the antiderivative from 1 to t of 1 over x dx. Okay, you need to highlight that part right there and say, this is the setup. This is the setup. If they ask for the setup in a problem, there it is. Okay, now I want you to do the antiderivative. And what's the antiderivative of 1 over x? Mr. Crawford, what's the antiderivative of 1 over x?
This is all you get. You're really not here.
Starts with an L.
1 over x. Is that what you're asking me? 1 over x?
What's the
What is the
antiderivative?
antiderivative of 1 over x? Starts with an L.
I would say L.
So it starts with an L.
Oh, yeah. Yeah.
That's right, Mr. Crawford. Natural log of x.
Exactly. You're welcome.
So, limit as t approaches infinity of the natural log of x evaluated at 0 or 1 and t. So the natural log of t minus the natural log of 1, limit as t approaches infinity, natural log of infinity minus the natural log of 1. Now I'm going to use my brain to calculate the natural log of 1. 0.
You can do that?
Yeah. So the answer is the natural log of infinity, which is what?
Infinity.
Infinity. So our answer is infinity, which means that this function is what?
Diverging.
Diverging. That's all there is to it.
It's actually not as complex as I thought it was.
Say again?
It's not as confusing as I thought it was.
Wait till you see the book. I would advise not looking at the book.
I don't think you'll have a problem with that.
Now, that's the first 2 or 3 problems we did on this section. Those are when you're given a definite B or A, and you're given an indefinite B or A, whichever the case may be. All right? What do we have here?
Indefinite.
We don't have any definites. We have both what? Indefinites. So whenever you have both indefinites, you're going to have to set it up from negative infinity to 0, and from 0 to what?
Infinity.
Infinity. So let's look at a graph representation. I have no idea what this looks like. I'm just going to use just a picture. Okay, I'm just going to use a wave or something like this. Okay? I have no idea what this looks like. This is just for instructional purposes only. Okay? Here is negative infinity. Here is positive infinity. In order to get this area, I have to use f of x, right here, f of x, and I have to use it from negative infinity to 0. So that would be antiderivative from negative infinity to 0, f of x dx. And then I'm going to have to add to this side, which is going to be from 0 to infinity, f of x dx. All right, so with this type of problem, since you have this right here, you're going to have to set it up as 2 integrations and just pick one. You can pick this one, or you can pick this one and do the limit theory with it. Just pick one. If it's divergent, then the whole thing is what?
Divergent.
Divergent. And most of the time, some of these will come out to be divergent, most of the time. All right? So if one is divergent, you need to write that down in your notes and highlight it. If one part is divergent, then the whole thing is what? Divergent. All right? So I want you to set this one up. I don't want you to do the antiderivative yet, because you got to use either integration by parts or use substitution. I haven't looked that far yet. I just want you to set it up as 2 antiderivatives. So basically all I got to do is erase the f of x dx and put that up there, and then put your limit out front. So I'm going to go over here, and I'm going to say limit as t approaches infinity, antiderivative from t to 0 of x squared e to the negative x cubed dx. Plus the limit as t approaches infinity of the antiderivative from what? From 0 to t of x squared e to the negative x to the third dx. So there's the setup. So it doesn't really matter which one you do. There's not an easy one or a difficult one. I'm going to pick the first one since we read from left to right. I'm going to pick the 0 to t, or t to 0, whatever the case may be. And we're going to check the antiderivative of that one. Now, it looks like to me that we're going to use substitution. Why not use integration by parts? You could use integration by parts. You could. But it would just be reinventing the wheel. Okay? So I'm going to make u equal negative x to the third power. U equals negative x to the third power. Du is equal to what? What's the derivative of negative x to the third power? Negative 3x squared what? dx. Hey, we got x squared right there. X squared, and we got a dx. So what do we need?
1/3.
A -3 inside and a -1/3 outside. So I'm going to take my red marker. And we need a -3 right here. And we need a -1/3 right here. Now again, I'm not worried about the limits. Right now, I'm focusing on what? The antiderivative. I'm not focusing on anything else. All right, now I need you to rewrite that. Well, what do you mean rewrite it, Hubert? Well, rewrite it like this because it may help you out if you rewrite it the way that you're actually looking at it. So I'm going to rewrite that as -1/3
Message coming in on secure.
-1/3 antiderivative of e to the -x to the third, and then -3x squared dx. Okay, now I want you to take a look, take your highlighter, and I'm going to highlight this, and that's right there. And then I'm going to highlight green. I'm going to highlight this, and that's that right there. So somebody tell me how I would rewrite my next interval. How am I going to rewrite it? It's not going to be in terms of x. It's going to be in terms of what? It's not going to be in terms of x. It's going to be in terms of what? The only letter I can use besides x, which is what? What's the only other letter I'm using besides x? I'm sorry. U. I'm going to rewrite this in terms of u. So somebody tell me how to rewrite this in terms of u. Since I just highlighted this stuff for you. Okay. -1/3. Oops. Antiderivative of e to the u, what? What is that yellow part?
du.
du. I think that's what you said. You got cut off. Now, what is the antiderivative of e to the u?
E to the U.
E to the u. You're done. So my final answer on the antiderivative is -1/3 times e to the what? U plus what? C. That's my antiderivative. Now, I know I can plug in u, and I'm going to in just a second, but we just did the antiderivative of all that mess, and all it was integration by substitution. So what is u? U is equal to what? -x cubed, Hubert. Yeah, that's right. So that's going to be equal to -1/3 e to the -x to the third plus c, which we really don't care about the c because we're going to plug in something. Okay, now there is your antiderivative for your first part. That's the only thing we're doing. We're doing the first part because we're going to see if it's divergent or convergent. So let's see what happens. Group. Okay, so I'm just going to go right here, and I'm just going to reset everything from here, 0 to t, limit from t goes to -infinity of -1/3 e to the -x to the third, evaluated at what? t and 0, right? T and 0. So, negative 1/3 e to the negative parentheses to the third power minus negative 1/3 e to the negative parentheses third power. And what goes up here? 0, Hubert. And what goes here? T. All right, finish it out. Because you got to plug in. Once you simplify it, you still got limit as t goes to what? Negative infinity. What's e to the 0? What's anything to the 0 power? Oh, that's what I heard. I don't know what y'all were saying. Y'all sounded like Jabba the Hutt. What does this go to?
1 here.
1. Good. Anything to the 0 power goes to 1. So this term goes to what? What's 1 times negative 1/3?
Negative 1/3.
Negative 1/3. Good job. Might want to check your calculator on that. 1 times negative 1/3. All right, now we're going to plug in, what is this right here? What's a negative times a negative? Plus 1/3 e to the infinity. Negative infinity. Well, e to the negative infinity is going to send you, and you have to look at the graph, basically to infinity. Okay? E to the infinity will give you infinity. So we've got, as a final answer, we've got 1/3 times infinity minus 1/3. What is infinity minus 1/3? What's $1 million minus 50 cents? Oh, come on, people. What's $1 million minus 50 cents? $1 million. Are you going to sit there and tell me you're going to take a calculator and say, okay, $1 million minus 0.50? What's infinity minus 1/3? I got the answer written right there. I just need somebody to say it. Thank you. I appreciate that. I know that was hard work. So, what is this function?
Divergent.
It's divergent. Since one of the parts is divergent, the whole thing is divergent. Question on that one? Can't believe some of y'all probably saying to yourself, I can't believe I'm doing this stuff. It's not that difficult.
Yes, that's what you're trying to say. Like you can.
What?
Just don't do it. Maybe.
I bet you can.
Yeah, but yeah. It doesn't change it. It doesn't.
What is it, Ainsley? What are y'all talking about?
We're
What's your
discussing
example?
how terrible of an example that was.
Why is it a terrible example?
Because you can't take.
You can take 50 cents from 1 million and it changes the number. But you can't take anything from infinity. It's still infinity. So we were all still kind of
Confused.
bumfuzzled.
You're kidding, right?
What? You don't think you can take 50 cents from $1 million?
I'm not even responding to that.
No, I'm confused.
We're genuine.
Yeah.
Have you ever heard drop out of a bucket? Okay, let's put it this way. Bill Gates' bank account, minus 50 cents.
The drop in the bucket.
There. Now you get it.
Yeah, I got it now.
Bucket of what he actually.
But it's still less.
Yeah, it's still less, whereas infinity is not less.
Yeah.
That's what I was.
Okay, well, if you're going to be like my ex-mother-in-law, then fine. Be that way.
Don't compare me to her. Don't put me on.
That's why people, when she's coming down the aisleway of Walmart, they go back the other way. All right. Here's an example of one that you're going to see in your book. Now, I just want to show it to you because now you should be able to do it by hand. And we're going to get to the other stuff. We're going to get to it. But with y'all, I believe we need to crawl before we can what?
Walk.
Thank you. Your parents did good. All right. 1 to infinity of 12 e to the negative 0.02x dx. Now what I want you to do is I want you to set it up, and then I want you to actually do it and tell me if it converges or diverges. First thing I would do is I would pull that 12 out. That's the first thing I would do, pull it out front. Now, since we have covered the derivative of e to x with something inside of it, you should know how to do the antiderivative of that because we've done like 3 problems with taking the antiderivative of e to a number x. So you should be able to do that. I'm going to use t as a variable. And this is a problem in the book, so therefore it will be a problem on the test. One of your business examples. Pendleton campus, you've been kind of quiet. Are y'all good?
Yeah, I think so.
Miss Caitlin, how are you? Are you good?
Yeah, I'm fine right now.
Now y'all had this class, right? Did he do this any by hand, or did he do it all on a calculator?
I don't really remember. I can go back and look at my notes, but like in our textbook, we didn't, there's nothing written down in our textbook for 6.1, so I'm guessing he either just wrote down examples, because there's nothing in my textbook that we actually did from the book.
He probably, before he even started, he probably went and did like I did and did substitution and integration by parts.
Yeah.
That's probably what he did because it's kind of hard to do these problems if you don't have those behind you. So,
right.
I just wondered. All right, so if you pull, first of all, you need to set it up. So let's set it up. So limit as t approaches infinity of 12 antiderivative of e to the negative 0.02x dx from 1 to t. And now I'm going to take the antiderivative of e to the 0.02x, and somebody tell me what that's going to be. E to the negative 0.02x over what?
Negative 1.
Negative what? 0.02 with the 12 out front. And then I'm going to evaluate that at 1 to t. Now, I'm going to go ahead and somebody take 12 and divide it by 0.02. What do you get?
600.
Say it one more time.
600.
Okay, so that's negative 600 parentheses e to the negative 0.02x evaluated at, well, that can be t. I'm sorry, that should be t. This should be t, so I can change this to x if you want to. 1 to x, and we'll say limit as x approaches infinity. Okay, so I'm going to change that to x. All right. So, do it. So I'm going to take my negative 600, and I'm just going to pull it out. Or I'm just going to leave it out. And then I'm going to write e to the 0.02 times 1, x, sorry, negative, minus e to the negative 0.02 times 1, close parentheses. Y'all make sure I copied everything down right. I think I did. I've got to move this thing. This thing's driving me bananas. I'm done hit my ankle twice on it. All right. So now, I'm thinking, hold on. I plugged in x, and I plugged in 1. So that's going to limit as x goes to infinity. So I'm going to do negative 600 bracket e to the negative 0.02x minus, somebody raise e to the negative 0.02. What do you get? Okay, so negative, okay, so that's going to be negative 600 parentheses e to the negative 0.02x minus, what'd you get?
9.980196.
Keeps going?
Yeah.
Okay. And did everybody else get that? E to the negative 0.02, did everybody get 0.98 blah, blah, blah?
Yes.
Okay. So now we plug in the infinity because there's only one place to plug it in. So negative 600 e to the negative 0.02 times infinity minus 0.98019 dot, dot, dot. Basically 1. Okay, the answer is 588. Okay? And write that down. That's the answer. Because you're basically, what's 0.98 minus 1? What's 1 minus 0.98? 0.02. And multiply 0.02 times 600. It's supposed to be 588. What does it come out to be? Yeah. Okay, that's not it. Okay, 1 e to the negative 2. Okay, let's look at infinity. 0.02 times infinity. 0.02 times 1, 0.02 times 2, 0.02 times 3, 0.02 times 100. It's going to be e to the negative infinity. So that's going to be negative 600 e to the negative infinity minus 0.98 ... Okay, let's look at negative infinity. Let's do e to the negative 1. So raise e to the negative 1. What do you get? E to the negative 1. Tell me what you get.
0.36.
0.36. What's e to the negative 2?
0.135.
0.13. Okay, what's e to the negative 5? Okay, what are we approaching? 0. So e to the negative, so you need to write this down. E to the negative infinity equals 0. You need to write that down and highlight it because you're going to see this again. E to the negative infinity is equal to 0. So that's going to be, I knew we were going to multiply by something, equals negative 600 times, let me erase this, 0 minus 0.98 ... And what does that equal?
If you do that, it'll multiply out and be 588.
588. I'm not going to put the decimals. I'm going to put ... Y'all, I'm not worried about that. If you get 588, I'm going to jump up and down and be happy. Okay? I'm not worried about the decimals. So, is this one convergent or divergent?
Convergent.
It's convergent because you actually get a what?
Number.
You actually get a number. Comprende? Okay. Now, I know it's about time. Some of y'all gonna have heart attacks, so we need to go ahead and talk about what we did today. All right. So this is what we're gonna do for homework, and I'm gonna work on it next couple of days. Y'all need to work on it. It's not a big deal. Okay. Just nobody's crazy on it. Homework that will appear. You will see probably a review of integration. I'll probably put out here, I'll put parentheses, power, sub, and parts. Everybody knows what that means now, right? And then I will give you a 6.1 homework. So be looking for those two things in the next day or two. All right, who's got questions for me? Now remember, I'll answer questions about the test Wednesday. I'm still grading your in-class test. Please don't worry about that. It's going to be averaged in with your other, or I'll take both of them and average them with the rest of the grades. I don't know what I'm going to do yet, but they should be good grades, unless somebody gaffed me off. All right. So the whole point is, worry about your tests. Those 3, 4, I think there was 3 or 4 people that the world came down and the sky fell on their house. Did y'all see that in China, where those people were in the escalator? Did y'all see that? And the roof fell on their heads. That's what happened to the 3 or 4 people. All right? Please, I'm not picking on anybody. Chill out.
That's a million Chinamen.
I'll give you a chance to do your test after Wednesday, okay? I don't want to mess with it today. Y'all have a good day.
You too.
All right, bye-bye.
Yeah.
I missed you, Hubert.
Yeah, whatever.
Good job, Hubert.
See y'all.
Good talking to you.
Yeah.